going to talk about the molecular shape of the molecules. So a molecule is atoms that are covalently bonded together, all right, and we've already done Lewis dot structures. So in order for us to get to the molecular shape, we have to know how to draw a Lewis dot structure for a formula, and then look at that Lewis dot structure and figure out what shape that structure is going to have. So basically, what we have to do is we need to think about the bonded atoms that we have, the lone pairs we have, and how many we have of each of those. So this theory that we're going to use in order to figure out these shapes is called the VSEPR theory. VSEPR stands for valence shell electron pair repulsion. Okay, so I know it's a long name, but when we have lone pairs, we have electrons in those lone pairs. Electrons, they're negative and they don't want to be close to each other. So they're going to spread out. As they spread out, they're going to be changing the shape of the molecules, which is why our valence shell electrons, and especially the ones in the pair, we know that they're going to repel each other. Okay, so like I just said, lone pairs the electrons in lone pairs are going to repel each other. That being said, lone pairs take up a lot more room than the bonded atoms do. All right, so the lone pairs and the bonded atoms together, with all the repulsion that's going on, is going to make the shape of the molecule. There are two shapes that we have to be concerned with. We have our electron geometry, and that's going to be kind of like your base shape. Your electron geometry is based only on the number of domains in that molecule. Okay? Your molecular shape is going to be the actual shape that that molecule takes on. And that's based on the number of domains, based on the number of lone pairs on your central atom, and the number of bonded atoms to your central atom. Okay, so the domain is the number of sections around your central atom. So we count lone pairs and bonds. If I have a molecule like SO2, if we're going to count lone pairs and bonds, we can see that we have 1, 2, 3 domains. Some of you might have wanted to count each of those double bonds, each as a single bond. What you want to do is, no matter what type of bond it is, whether it's a single bond, a double bond, or a triple bond, you're always going to be counting it as just one domain. So sulfur dioxide would have 3 domains. Okay, bonded atoms. It's the number of atoms bonded to the central atom. That is all we're concerned with, the atoms actually bonded to the central atom. So if we were looking at sulfur dioxide, we would have 2 atoms bonded to that sulfur. The lone pairs, we're only counting the number of lone pairs on the central atom. Don't worry about these lone pairs. We're only worrying about the lone pair on sulfur. Okay, so like I said before, those lone pairs that we have are going to really make the difference in the shape of a molecule. So when we think about the shape of the molecule, in between each of the bonded atoms, there is going to be an actual angle, so like a degree sign that we can measure. Okay, so it's going to be the number of degrees between each of the atoms. The more lone pairs that you add, the smaller the bond angle, because those lone pairs are going to spread out and spread up and take up so much space. So the atoms are going to be pushed closer together. So when you have one domain, it's going to be 180 degrees. So from this atom to this atom is a straight line, and that's 180 degrees. Same thing for 2 domains, okay? The angle from here to here is still a straight line, and that is 180 degrees. When we have 3 domains, like we do in this example, each of these is going to have a 120-degree angle. When we have 4 domains, okay, each of these is going to have 109.5-degree angle. As we get these down to different molecular shapes, so if we're adding lone pairs, each lone pair you add, you're going to subtract 2.5 degrees. So each lone pair, you subtract 2.5 degrees. Okay, now we have hybridization. Hybridization happens when we're actually forming these molecules and different energy levels need to come together to form a hybrid orbital. So that's something that has energy in between the 2 different energy levels. Okay, so the actual quantity of energy is in between the higher and the lower one. So it comes together so that the atoms can come together and form a molecule. So when we talk about hybridization, we're going to mainly be talking about the hybridization of s and p orbitals. If we get into expanded octets, which we don't really need to worry about much, we also could have our d orbitals involved. But we're going to talk about our s and our p orbitals. So whenever you have one domain, it's going to be an s and a p. You have 2 atoms that are connected together, so you have 2 letters. 2 domains, you're going to have 2 atoms around the center atom, so you still have 2 letters, S and P. 3 domains, you have 3 atoms around the center. So you have 1 S and 2 P's. So now you have 3 letters, 3 atoms around the center. 4 domains, 4 atoms around the center. You have 4 letters. You have S and then 3 P's. Put it all together, and you have sp3. So I know that was a lot of information, so let's see how we're going to apply that information. So let's do some examples. If I'm going to be asking these types of questions, what I'm going to be asking for is the Lewis structure. I'm going to be asking for the electron geometry. I'm going to be asking for the molecular shape. I'm going to be asking for the bond angle. I'm going to be asking for the hybridization. Those 5 things. So if you didn't write those down, make sure you write down those 5 things. You can rewind the video and see what those 5 things were. Okay? So first, SiO2. In order to draw this Lewis structure, I need to first figure out the number of valence electrons. So silicon has 4 valence electrons. Each oxygen has 6. So now I'm going to end up with a total of 16 valence electrons. So now I'm going to have to draw my molecule. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20. Too many. 2, 4, 6, 8, 10, 12, 14, 16, 18. Still too many. 2, 4, 6, 8, 10, 12, 14, 16. I'm good. I have the right structure now. Now I need to figure out what my electron geometry is. I want to figure out, in order to figure out what my electron geometry is, I need to figure out the number of domains I have, the number of lone pairs I have, and the number of bonded atoms. So D is going to stand for domain. 1, 2. I have 2 domains. LP is going to stand for lone pairs. Do I have any lone pairs on the central atom? No, I do not. So it's going to have 0. And bonded atoms, we have 2 atoms bonded. Okay? Now with that, I can figure out what my electron geometry is and what my molecular shape is. This is where the memorization comes in. You need to know if I have 2 domains, no lone pairs, and 2 bonded atoms, I need to know that the electron geometry is going to be linear, and I have to know that the molecular shape is also linear. If I have an electron geometry of linear and a molecular shape of linear, that means that my angle is going to be 180 degrees, and my hybridization is going to be SP. We have two atoms bonded to the center atom, okay? So you have two letters, S and P. Let's do NH3. So I need to figure out the total number of valence electrons I have. So we have 5 plus 1 times 3. That's going to be 8 valence electrons. All right, then I'm going to draw my lowest dot structure, 2, 4, 6, 8. I'm good. All right. So now I'm going to figure out how many domains I have. I have 1, 2, 3, 4. How many lone pairs do I have? I have 1. How many bonded atoms? I have 3. Okay. My electron geometry, my molecular shape. So my electron geometry, I know that I have 4 domains, so that is going to be a tetrahedral. Now molecular shape, this is going to be one of the more complicated ones. So you can go to your little chart, okay, and we can look up, okay, I have 4, and so I have 4 domains, and I know that I have 3 bonded atoms and 1 lone pair. So that is trigonal pyramid. Like I said, you have to memorize these. But before you do memorize them, maybe you just want to use this as a double check. But on your tests and quizzes, you cannot use this chart. Okay. So then we're going to have our angle. And we have 4 domains. It's going to have an angle of 109.5. And if we wanted to be fancy, we could subtract our 2.5 because we have 1 lone pair. So it would really be 107, okay? And our hybridization is, we have 4 domains, so it's going to be sp3. Okay, I have 2 more examples here. I have BH3 and I have CCl2. If you do these 2 problems, and if you get them right, I will give you 2 extra credit points. So make sure you show them to me when you come into class.